How to fix your window air conditioner. I'm going to use a piece of shit as a model example. We've got a 1969 Sears power sucking 8000 BTU boat anchor here that we're going to teach you with. Well, the most common problem with air conditioners is they're plugged with dirt. When it's running, the vents on the side allow air to be sucked in by the fan, and it gets blown out the back to the part you're familiar with. And of course, those are what the side vents look like. Well, no dirt builds up here, but a lot of dirt builds up in here. This one must have been cleaned because it looks good. Using the front coil as an example, that's kind of what they look like. They're plugged up with everything. Well, the best way to clean them, and it doesn't cost anything, is take the cover off, remove the screws that hold the radiator in, and carefully move it over a little bit. Take a wire brush like you use for scraping your barbecue with or scraping rust off with, and with straight strokes down, up and down, take off all the debris. And then I use compressed air. You first blow in through this way so it takes it off. Then once you're done systematically blowing it that way back and forth, then blow it all over. Blow out all the crap that builds up in the bottom, the dried algae and everything else, so more chunks don't get sucked in by the fan and deposited. Obviously this unit was very dirty at one point in time, because when they're dirty it works the compressor too hard, then they draw too much electricity, and then they cook the cords. See? That causes fires. Never use your air conditioner on a long extension cord either. The extension cord gets hot and causes fires. Use short extension cords designed for air conditioners. When an air conditioner is working normally, the running pressure on the low side pipe is between 64 to 67 psi. Now they don't have a way to hook up and test that because the pipe where they charge them in the factory is welded shut. So you get one of these bullet piercing valves. They don't have to be bullet brand. And somewhere on the largest diameter pipe, which is the low pressure, or on the dead end fill pipe, you have to find a very straight surface that's smooth. Take a piece of steel wool and clean off any dust or debris or oxidization. Clamp this thing on with the appropriate spacer so it bites the pipe correctly. Then tighten down the set screw in the middle last. That pokes a hole in the pipe. Never remove it afterwards or all your freon comes out. Hook the low pressure line that goes to this gauge on your manifold, the blue one, to this device. Turn the air conditioner on, set it to maximum fan speed, thermostat maximum cold, run it for a few minutes, and charge it to the appropriate pressure, 64 to 67 psi. If the unit's low on gas, some of these coils will contain frost all the time that it's running. It's not uncommon for them to contain a little bit of frost when you first start them up. But if they still have frost after 5 minutes and it's a warm day, you're low on freon. On window air conditioners, the most common place they leak freon is the radiators, especially the back one. All the corrosion that happens at the bottom, and that liquid just sits there and eats the tubes that pass somewhere through all those fins, and they seep out very slowly, and there's no way to fix them. Sometimes happens a bit on the front radiator too. Common place is this thing called a cap line. It's a thin little tube that freon actually passes through that looks like a wire. Sometimes the cap line vibrates against itself or against the metal body or some other pipe and wears a tiny hole through. That's actually not hard to resolder. You don't even have to cut the pipe sometimes. If you do have to do any kind of soldering on your air conditioner to fix a leak, well, since you've already got a break in the system and there's air in there or whatever, I prefer to use these little sweat-on valves, as they're called. So you just cut this off, leave a gaping hole, that's your charging tube, stick it in, and solder it in. Works the same as the other one. Now, don't use lead solder on air conditioners. This is called silver solder, or another name of a product that works better is called Silphos. If you use this product to fix a joint or to fix a hole, the pipe just has to be a little bit clean when you use Silphos. It's self-fluxing, works wonderful, it's so easy to use and it's so strong. If you're repairing a pipe wherever on the system or making a joint, you want to use silver solder, then you have to buy a white pasty flux and sand the joints and clean them very well, and then silver solder them. You cannot do your silver soldering or silflux job with a propane torch. If this had a MAP gas bottle on it or some higher temperature gas, yes, it will work, but I don't like that. It doesn't work as well. I do all my joints with the heat of an acetylene oxygen torch. It does the job so fast. And you don't get a cold solder joint, so there's less chance of getting a leak. But be careful, it is hot enough that it melts copper very easy. So if you think your piece of shit's leaking Freon, the very first thing to do is an inspection. Look at every little joint, every place where the steel touches a pipe. That can be where it leaks as it wears its way through. Every solder joint, every place where a pipe could be rubbing, stuff like that. Look for an oil spot. Sometimes, if the water doesn't wash it off, there's an oil spot, and that's a great clue. And of course, another method is your handy dandy electronic leak detector. Just turn it on as it's beeping away like a Geiger counter. You're sniffing the pipes, you're sniffing the joints, you're sniffing every little place where a tube could have a fracture. This doesn't work very good trying to sniff the middle of the radiator, unfortunately. If you're recharging an air conditioner that doesn't have vents on the side and you have the cover taken off, it could be a sleeve air conditioner like the one at the bottom. It doesn't have vents on the side. You have to run those with the cover on, at least loosely, while you're charging them, or turn the cover upside down and cover up this gap so that it keeps air pressure in there so that all the air can pass through the radiator so your air conditioner doesn't overheat while you're charging it. It's very important when you're charging your air conditioner to watch the gauge. As soon as it gets to the right pressure, you know, no more than 67 psi with the fan on high, stop. If you add more gas, your compressor and air will be overworked and your air conditioner will actually produce less cool. And then what starts to happen is it starts to cool off the pipe so much that the pressure starts to go down again, and then you think you have to add more gas, so you add more gas, it looks like it's taking and going up, but then the pressure goes down again. It starts overcooling the pipe, overworking the compressor, and teasing you and making you think you need to add more Freon, but you don't. You do not want to overcharge it. Now for the electrical faults on air conditioners. Of course, like I just mentioned, fried cords. If you see any burning around your plug and it still looks in great condition, sand it so you can save it. If it looks, of course, like this or a little bit worse than you'd feel trusting sleeping with, well then just snip the end off and put a new heavy duty end on or replace the whole cord. Now if you've got a dead unit or the fan comes on but the compressor doesn't, it's very common for one of the heavy wires on the switches in here just to burn off. Then you just have to cut back the burnt wire, put a new end on, and it's fixed. And then sand the terminal where it slides onto. It often happens inside the little compressor pin cover too. They burn off there regularly also. If you go to turn your air conditioner on and the compressor just goes click, well, you very well could have a bad compressor, but you could have a bad capacitor. Some air conditioners have one capacitor. It does fan and compressor. They would have 3 sets of terminals. This one has a single capacitor which just does the compressor. 2 sets of terminals. Well, what you do if your compressor doesn't want to start and a good kick doesn't help it either, change that capacitor. There's no polarity, so you can hook it up either way. And try it again. If it still doesn't start, well then your compressor's probably fucked. Next is the fan motor. Always give it a twirl when you first open up your air conditioner to see that it doesn't slow down too quickly and that it does spin freely. This one's good. The bearings very often seize up on your fan, and then of course your air conditioner can overheat and that'll take out the compressor and kill it too. Some really old motors actually have little oiling places, and it's always a good idea if you have the cover off to oil both little holes. Use light oil, like 3-in-1 oil or something about number 10 weight. Not engine oil, it's a little bit too thick. Or automatic transmission oil works great on electric motors. If your fan motor spins freely and is just sort of humming but not taking off by itself, check someplace in the unit. Could be here, could be in the switch box, could be over here, could be actually mounted to the fan body, but you might have a fan capacitor. Fan capacitors are a lot smaller than this one. They're usually only about that big, about that high. They range anywhere from 3 to 7.5 microfarads. Change your fan capacitor with one known to be good. Then try your fan again. Turn it on. If it doesn't take off by itself, or if it only takes off when you give it a whirl, well, with a good capacitor and it doesn't do that, well, then you've got a bad fan motor. So good luck. Replace it with another one or chuck it. If you want to change the compressor in an air conditioner, you have to size it. First the physical size, then the shape of the mounting plate and where the holes are. Some air conditioners like Tecumseh compressors have a plate with a thing you can knock off the bottom and rotate the plate to different positions, or switch plates on them to make the compressor more universal. The easiest way to size them is by their LRA reading, locked rotor amps. That means how much power the compressor draws. If you don't let the motor inside turn, you hold it back. This one says 50 LRA. So it's a 10,000 BTU compressor, although they've put too big a one in this machine because it's actually an 8,000 BTU and it's using more hydro than it needs to use. A 46 to 47 LRA compressor is for an 8,000 BTU, and a 6,000 BTU would be 31 locked rotor amps, and a 5,000 BTU would be 28 locked rotor amps if we're talking about an oval style piston compressor. Rotary compressors, unlike those ones, look completely different but work in a similar way. You can actually switch a rotary for a oval compressor or vice versa. Same thing. Their locked rotor amps are usually slightly different value. This one's a 47, so this one's an 8,000 BTU, but they're usually close to the same, so sizing them isn't that hard. Of course, when you use one of those, the mounting base is much smaller, so you've got to re-drill 3 new holes in the bottom of your air conditioner and put some more different bolts in different places. So basically, once you've matched the power capacities of your compressor, or you know they come from a similar BTU of the one you're working on, it doesn't matter what kind of compressor you put in. As long as you can make it fit and put the cover back on, it's going to work. Freon is not harmless to people. It also burns your ass when it gets up there in the ozone and allows all those rays to come in that you don't want. But when you heat up Freon when you're welding with your torch or doing any repairs, it does become a deadly poisonous gas which will burn your eyes and destroy the lining of your lungs. It's just horrible. Don't ever try to ignite a torch where there's Freon coming out. It doesn't burn, but it will burn your lungs. And it may sound hard to believe, but all window air conditioners and all central air conditioners on your building or your home use R22 gas. Well, not quite all. In the last couple of years, there's a new couple different kinds of gas for central air units. But the gas is interchangeable for every other system in the world, so you can work from big ones to small ones, all with the same bottle, which is called R22. And of course, if you don't have your charging manifold gauge set to recharge, but you do have some Freon and you do have a hose, or you actually have 2 air conditioners and you want to be a vampire and suck Freon out of one and put it in another, then you just need 2 of these valves, 1 hose, attach the 2 together. Doesn't matter what pipe you attach to when you're sucking Freon out of an air conditioner, any pipe will work. It makes no difference at all. But when you're charging it, you always choose the largest pipe and hook the valve on a smooth area, or weld it onto the charging pipe. You would just screw the hose onto the valve that would be attached in this large pipe, turn the air conditioner on full blast, attach it to any pipe on your donor air conditioner. While running this one and charging it, they only charge while they're running, then it's sucking Freon in. Keep feeling the pipe. When the pipe starts to get pretty cold, stop. That means it's charged. Sweet, cool, and true redneck.